Okay, the following is a video over 3-7 notes, and this is the chain rule. The chain rule is probably one of the most important things that we do as far as taking derivatives. This rule will allow us to really almost take the derivative of any function. We still have some more different types of functions that we want to look at, but this is really huge. Okay, so this es muy importante. All right, the first thing I want to do, let's think about taking the derivative of this function, the quantity x squared plus 6 quantity squared, okay? Now, the only way that we could do this is if we wrote it as x squared plus 6 times x squared plus 6, okay? And if we multiplied it out and we got x to the fourth plus 6x squared plus 6x squared, and then plus 36, okay? And that's my function f of x. If I combine my like terms, I'm going to get x to the fourth plus 12x squared, and then plus 36. Okay, and if I wanted to calculate the derivative, I just use the power rule, and it's pretty simple, and we're going to get 4x cubed plus 24x, and that's it, okay? So that's the derivative of my function f of x. Okay, this is my derivative, 4x cubed plus 24x. And so what I want to do is look at another method. Now remember that we're supposed to get f prime of x to be 4x cubed plus 24x. Okay, so what I want to do is try and do the power rule without multiplying this out, okay? And so what I see here is that I have this quantity, x squared plus 6, raised to a power, okay? And so if I wanted to calculate its derivative, f prime of x, you can think of this quantity here as its own quantity, but we're squaring it. So when we do the power rule, I want to bring this quantity down. So I get 2 times x squared plus 6 to the first power. Okay, now what I want to do here is let me multiply through this 2. Okay, f prime of x is going to be 2x squared plus 12 after you distribute your 2. Okay, so here's the thing, guys. I didn't get 4x cubed plus 24x when I did that method. Okay. However, the question is, what would I have to multiply this function by? What would I have to multiply this function by in order to get 4x cubed plus 24x? Okay. So what I see, to get from 2 to 4, I'd have to multiply by 2. To get from 12 to 24, I would have to multiply by 2. So if I took my derivative here, and I wrote this as the quantity 2x squared plus 12, I ultimately need to multiply by 2. Okay, so I'm going to multiply that whole thing again by 2. But then to go from x squared to x cubed, I would need to multiply this by an x. To get from no x to an x, I would need to multiply by an x. So if I multiplied this function by 2x, and I distribute that into my thing here, okay, then I'm going to get f prime of x is equal to 4x cubed plus 24x, which is the derivative that I'm looking for, okay? But here's the thing, guys, okay, and here's what I want you to see. We did the power rule, brought the 2 down, subtracted 1, but then we had to multiply this entire function by 2x. And 2x is very important because 2x, if you notice, is the derivative of x squared plus 6. Okay? So that's interesting. So if I take my normal derivative, leave my function the same on the inside, then in order to get the derivative that I need, I have to multiply this by 2x, the derivative of my inside function. Okay? So what I want you to do is I want you to now describe the process that was used in method 2. Describe what we did. Okay? And I want you to do that on your own, and we're going to take a look at that in class. Okay? So pause the video, go ahead and write that down. You may want to rewind the video just to see, but I'm going to go ahead and move on and look at this new method of doing things. Now, here's the thing. Here's why we would need something like the chain rule, okay? If I wanted to calculate the derivative of this function g, doing the old way, I would have to multiply out this binomial 100 times. And I would get a very, very, very long polynomial. But you know what, guys? We don't have time for that. Ain't nobody got time for that. So what I want to do is use that same principle that we had just done. Okay, so what I see here is that I have an inside function, okay, and then I have an outside function, okay? And I'm going to talk more about this later on. But my outside function is some quantity raised to 100. And my inside function is, you know, a simple standard polynomial, 4x to the 5th plus 6x. So what I want to do here is do the same thing that we did. But before I do that, I want to let my inside function be a value of u. So I'm going to let u equal 4x to the 5th plus 6x, okay? And so what I'm going to do, I'm going to rewrite g of x as some value, the quantity u to the 100th power, okay? So what we, if we were to calculate the derivative here, g prime of x, then I would do my normal power rule, okay? And I would drop the 100 down, multiply it by u to the 99th power. But then, remember what we did before, remember what we talked about, is that I had to multiply by the derivative of my inside function. And I'm going to call that u prime, okay? So if I took the derivative here, u prime, let me, if I could write the letter u, it'd be a little bit better. Okay, u. So if let me take the derivative here and find u prime, so that's going to give me 20x to the 4th and then plus 6, okay? So what I want to do now is I want to go back here, write my derivative, but resubstitute my values in for u and u prime. So if I find g prime of x, then that means I'm going to take 100 times the quantity, which was u. Okay, now u, we're going to have that be 4x to the 5th plus 6x. We're going to raise that to the 99th power. But then we want to multiply by the derivative of that inside function, and we're going to multiply by 20x to the 4th and then plus 6. Okay, and this is my derivative. Okay, so we don't have to go any further than this. You know, this is unsimplified, but you know, this is a lot, much easier than multiplying this binomial out 100 times, simplifying all your stuff, and then doing the power rule. This is much simpler, okay? So let's think about the chain rule as a definition, okay? And basically what I have here is I have a composition of functions. So this is a composition, okay, of functions, all right? And basically when I say compositions of functions, I mean functions within functions, okay? Functions within functions, okay? One, if you've seen the movie, or one may think of the movie Inception, where you have dreams within dreams. When you have compositions of functions, those are functions within functions, okay? So they're incepted, sorry, let me write incepted functions. So incepted functions, okay, functions within functions. Okay, so let's think about that. What does that look like? If I have f of, and I'm going to switch up my colors here and write g of x, I don't want that last parenthesis, f of g of x, and g of x is the inside function. Okay, so here's what I want to write. I'm going to write f is the outside function, and I want to write that g is the inside function. Okay, so what I wanted to do, if I took the derivative with respect to x here, okay, of this composition of functions, of these incepted functions, then here's what I end up getting. Okay, I'm going to end up getting the derivative of my outside function, so f prime of g of x, okay, of g of x. And then I'm going to then multiply that, okay, multiply that by the derivative of my inside function, g prime of x, okay? So we take the derivative of our outside function, and then we multiply by the derivative of our derivative outside and multiply by the derivative of the inside. Leave the inside, okay? So then what I want to do is, let's look at an example, and let's kind of see how I would go about doing this. We've kind of already done that, but let's take a look at number 10 here. Okay, let's identify our outside function, okay? Or let's first identify our inside function, okay? So I'm going to call this the function u, okay? And I do that a lot. Make sure it looks like an actual u, okay? So if I let u equal 4 minus 3x, okay, then what I want to do is I want to rewrite my original function as y equals the quantity, some quantity to the ninth, okay? And that's the idea, is that you see some quantity to the ninth, all right? And I put my u on the inside, okay? And if I took my derivative with respect to x, if I took the derivative of this whole thing with respect to x, d dx, then one thing that I want you to see here is that the x and my variable u don't match. And since those things don't match, I have to use the chain rule, okay? U is a function. It's 4 minus 3x. So what I would end up getting here is I end up getting dy dx, okay, which is the same thing as me saying y prime. Those are nouns. And that's going to be equal to 9 times the quantity u to the 8th. So I'm going to take the derivative of my outside function. I'm going to leave my u on the inside, but then I have to multiply by the derivative of my inside function, which is u prime. So let me find u prime real quick, and u prime is just going to be, what is that, negative 3? Okay? So now what I'm going to do is I'm going to chain everything back together, hence the chain rule. So I've got dy dx is equal to y prime, okay? And that's going to be 9 times the quantity, 4 minus 3x, that's what u was. So I substitute this back in, I chain it back together, so I write 4 minus, I'm going to change back to red. Okay, I'm going to do 4 minus 3x, and then I'm going to square, then I'm going to raise that to the 8th power, okay? And then I'm going to multiply by the derivative of my inside function, multiply by u prime. So then multiply by negative 3. Okay, and we can simplify this a little bit. We end up getting that y prime is going to be equal to negative 3 times 9 is negative 27 times 4 minus 3x to the 8th power. Okay, so that's our derivative, okay, using the chain rule. Now, you could multiply this out 9 times, but that's no fun, okay? I think this is a little bit more fun. So I'm going to go ahead and stop the video there. I'm going to do a bunch of practice problems. I'll probably do about 2 or 3 more videos after this. Some of these problems get pretty involved, but that's the idea, okay? These are pretty simple because we have to just do one chain rule. Sometimes we'll have multiple chain rules, okay? So hope you enjoyed this video. I had just an absolute blast making it.